Young people, welcome back. BMB in the house, y'all. Really excited about this one, y'all. So excited, I'm gonna tell you this right now. I don't even know what they're talking about. So, chapter 2, lesson 8, literal equations and dimensional analysis. What? The HE double hockey sticks? Huh? Objective 1, solve equations for given variables. I get that. Objective 2, use formulas to solve real world problems. Okay. So students will be able to solve equations that are formulas. And students will be able to solve for a given variable in a formula, I guess. So the concept is equations. We're gonna go linear, and the skill is solving. So we're doing the same thing, guys, and we're gonna have a lot of fun with it. And trust me, I know what's going on. It's just sometimes these books, right? Let's take a look and get her done. Boom. And don't get me wrong, great textbook. I love McGraw Hill. Chapter 2, lesson 8, guys. Nice long handout. 20 questions. So if that's 1 minute per question, that's a 20-minute video, 25-minute video. You guys know we like to keep it in a timely fashion. So let's make sure we do that. Solve each equation or formula for the variable indicated. So it looks like they're going to give us an equation such as 7t equals x and solve for the indicated variable, not with a highlighter. Get that out of there. No, we want it with a beautiful colored pen, such as white. So 7t equals x, and we want to solve for t. So what's happening to t? T is being multiplied by 7. The opposite of multiplying is dividing. So the opposite of multiplying by 7 is dividing by 7. And guess what? Inverse operation, and you're done. T is equal to x sevenths. I'll say that again. T equals x sevenths. X divided by 7, guys. Just having fun with it. Over here, we got the equation R equals WP. What's R? I don't know. What's WP? I don't know. But I can solve for P. What's happening to P is being multiplied by W. The opposite would be divide by W. Do it to one side, do it to the other side. And there I go. The W's cancel on the right side. I'm left with R divided by W equals P. And we solve for the indicated variable. I love it. Let's get some more in, guys. Slide it. Well, don't slide it. Let's just get rid of it. And here we go. Next 2. Or maybe next 3. How many we can fit in here? Got 2. Number 3, hey, look at that. I got 4. So, number 3, Q minus R is equal to R. We want to solve for R, okay? So in this situation, it looks like I got R on the left side and the right side. So we need to isolate the R. Go ahead and get your variable that you need on the same side, guys. So if I have an R on the left and an R on the right, let's get them together. So go ahead and add 1 R, or just R, to both sides. That's going to eliminate the R on the left side, your negative R. I get Q is equal to 2R. So now if I'm solving for R, I can divide by 2 and get R by itself and have a final answer of Q divided by 2 is equal to R. Basically, a 2-step. We did 2 inverse operations. Added R and divided by 2. Over here we got 4m minus t is equal to m. So again, solving for m, I've got 2 m terms. On the left side I got 4m, and on the right side I got 1m, the invisible one. So let's go ahead and, no need to actually do this. I don't know why I'm doing it like this, but I guess sometimes I just do what I do. So adding t to both sides, I get why I'm doing it. I just figured that out. So 4m is equal to m plus t. I still can't just have m on the left and m on the right, those m variables, those m terms. So let's go ahead and get m all on the same side. So subtracting m from the right, subtract m on the left, gives me 3m is equal to t. Now I can divide by the coefficient of 3, and m is equal to t divided by 3. So moving that t to the right side, I could have did that later, but eventually it would have to get over there. So it doesn't matter what order you do your steps, as long as you do your steps to correctly get the solution that you're looking for. And in this case, guys, the solution for the given variable, because we have multiple variables in these equations. It's not just an x. We got an a, and we got a b. So 7a minus b is equal to 15a. What are we solving for? A. So I got 7a on the left side and 15a on the right side. So indicating here again, guys, my variable term, 15a. What about that 7a? Doesn't get highlighted? 7a is probably going to get a little upset. You can get a little shady there, huh? Oh, maybe because I'm moving it. Moving the smaller variable term. So subtracting 7a from the left, subtracting from the right. I love that now I have a negative 1b. Can't forget that negative. Is equal to 8a. So divide both sides by 8. So that a will be by itself on the right side. I get a negative b divided by 8 is equal to a. So again, guys, that was 2 steps. First step, I moved the variable term, 7a, to the other side. And then, of course, the second step I did was divide by the coefficient 8. So in this one, guys, I'm doing the same thing. I got a c term on the left and a c term on the right. Can't have that. Move the smaller one, so I deal with positives. So the negative is smaller than positive. So add it, 5c on both sides. The d comes down, and d is equal to 7c. To get c by itself, get rid of the coefficient. Divide both sides by 7, and you get your final answer of d divided by 7 is equal to c. So again, guys, 2 steps. And let's get it on out of here. Because, remember those other 2 I thought I had room for? Didn't have that room. So here we go. Again, I've got x minus 2y equals 1, and we want to solve for y. So in this situation, guys, I would ask, so what's happening to y? Well, y is being multiplied by a negative 2, and they're adding x to it. So what do we want to undo first? Undo the adding of x. The opposite of a positive x, and that's why I say adding of x, because it's positive, would be to subtract x. You like that new color? I hope my editor does too. So negative 2y is now equal to 1 minus x, or the way that I'm writing it here, negative 1x plus 1. Kind of looks like slope-intercept form, y equals mx plus b. Yeah, we'll see that later on in the book, guys. Getting y by itself means getting rid of the negative 2 in front of it, so divide both sides by negative 2. And here, guys, it's important that you know what to do when there's addition in your numerator and you have a denominator. So negative 1x divided by 2 and 1 divided by 2. So negative 1/2 x minus 1/2. So looks good, feels good, guys. You notice here I did put the inverse operation in a different color, in red. Let's see if we continue that trend. For number 8, d plus 3n is equal to 1. I'm going to go ahead and subtract d from both sides. Not a different color. But still the inverse, opposite of positive d, negative d. So 3n is now equal to 1 minus d. So we can divide both sides by 3 so that n can be by itself, because that's what I'm solving for. And again, I'm going to have 1/3. Oh, I didn't separate this time, which is okay. Unless the teacher says, no, I need you to separate those operations. I'm sorry, I need you to separate those terms. Okay. When I say terms, the numerator has a 1 and a negative d, so consider that 2 terms, but they're both being divided by 3. All right, guys, so 9 and 10. Looks like it's not getting more challenging, at least not in my eyes yet. I still have 7f plus g equals 5. Only 1 term on the right, 2 terms on the left, and the one I'm solving for has a coefficient. So if f is what I'm solving for, get rid of the g that they're adding to it. 7f is now equal to, and whether you say negative 1g plus 5, or you say g minus 1g, or you just go ahead and say 5 minus g, because we know it's all about that g. And there we go, guys. When I divide both sides by 7, f is by itself, and I can leave it as 5 minus g divided by 7. We showed earlier on how to separate the fraction when you have 2 terms in the numerator. Well, here, guys, we're going to solve for x. So get rid of the c that they're subtracting from it. Always undo the addition or subtraction first, just like a 2-step equation. So adding c to both sides, now it's going to give me ax equals b plus c. This is the first one where there's no numbers at all. It's all letters, right? Divide by that. And now I can't say the number in front. Divide by a. Because ax If I want x by itself, get rid of the multiplying of a by dividing by a. And there we go, guys. When I do it to both sides, again, leaving it as that fraction b plus c, all divided by a. All right, guys. I'm feeling good about this. Looks like, again, number 11 and 12, we've got one term on the right-hand side, two terms on the left-hand side. So, RT minus 2n is equal to y. Solve for t. So is there any multiplying happening to t? Yeah, by r. Is there any addition or subtraction happening to t? Yeah, they're subtracting 2n. So what's the opposite of subtracting 2n? Adding 2n. So when I add 2n to the left side, I gotta make sure I add it to the right side, recognize that I put it not underneath the y, but next to it, because I know they're not like terms. I'm not actually going to add them up. I'm going to rewrite the equation the way it needs to be written. RT is equal to 2n plus y, or y plus 2n, commutative property, you can flip those, right? To get t by itself, you need to get rid of the r, so the opposite of multiplying by r is dividing by r, so it's both sides, and t is now equal to 2n plus y, all divided by r. Oh, I did my separation. Yay. So there it is again, guys, showing with a better plus sign how you can separate because you have two terms in your numerator. Just keep that same denominator, right? All right, guys, so BC plus 3G is equal to 2K. So not the 2K you like to play, but this 2K. Now, I'm going to go for C. Go ahead and get that highlight. And again, what's happening to it? They're multiplying by B and they're adding 3G. Opposite of adding, subtracting. And we do that before we deal with any multiplication or division. So subtracting 3G from the left, subtracting 3G from the right, BC comes down, and BC is now going to be equal to 2K minus 3G. And I like it because the minus 3G is better than me saying negative 3G plus, oh, I need to say negative, just keep it as subtraction, right? Getting the C by itself means getting rid of the B that's being multiplied by. So when you divide both sides by B, you're going to get this final answer of C equals 2K minus 3G all divided by B. Final answer. All right, guys. So a good halfway through, I believe. And we're still working on the same skill. These have not been formulas, at least none that I know. But again, we're going to get to the point where some of the formulas you may know, like area, perimeter, those will be some of the ones that we use. But back to the nifty. Kn plus 4f is equal to 9v. I want to solve for n, so definitely get rid of the term that's being added to the n term. Say that again. Get rid of the term that is being added to the n term. The n term was kn, and they were adding 4f, so I subtracted 4f from both sides, leaving me with just kn on the left, which is now equal to 9v minus 4f. And then, of course, gotta get n by itself, so divide by k both sides. Same process here, guys. 8c plus 6j is equal to 5p. So even though there's only one term on the right side, it's p. It's a p term, 5p. So 5p and 6j, or negative 6j, are not like terms. So I'm just looking at 5p minus 6j. Okay, I'm all right with that. And then, of course, if I want to solve for c, I cannot have that coefficient. And now I'm calling it a coefficient because it is it's an integer, it's a number, right? It wasn't kn or ax or pw, it was 8c, and I can divide by 8, which is our coefficient. Final answer with the separation. And I like how I put the p and the j hanging off to the side because, again, 5/8 p minus 6/8 j. This sounds good, right? All right, guys, and ooh, I know what we're doing now. How do you undo dividing by 2? Multiply by 2. So since I want to solve for x is in the numerator, well, I need to get rid of the denominator. So 2 goes into 2 one time. That's how I get rid of it. Multiply both sides by 2. So now 2 and 2 will cancel each other. The red 2 and the white 2 will cancel each other. You're left with just x minus c now is equal to 2 times d, or 2d. Add c to both sides and boom, you're done. So now guys, I could say it 15 times or I could just say it one more time. How do I undo dividing by 2? Multiplying by 2. So here it is again. X minus c divided by 2 is equal to d, but this time let's solve for c. Well, nothing changes, guys, except do you recognize c as a negative 1 in front of it? So x minus c is the same as saying x plus a negative 1c, or x minus 1c, or x minus c, right? I get it, I understand it, and I hope you do too. But again, c is still being divided by 2, and the opposite of dividing by 2 is multiplying by 2. So I'm going to multiply both sides by 2, which will eliminate my denominator. And if you don't know why, I'm about to show you. 2 times the fraction, or rational expression, x minus c all divided by 2. Well, top times top gives me 2 times the quantity of x minus c. Bottom times bottom gives me 2. Guess what? 2 goes into 2 one time. I just got rid of the denominator. So now it's just x minus c is equal to 2d, and 2d. So to get the c by itself, guys, oh my goodness. Yeah, I need some room, huh? How much room are you gonna need? So, recognizing, guys, that we were just about there. A lot of people just know, just gotta get rid of the x, right? So x minus c is equal to 2d. Subtract x from both sides, knowing that c is negative. So negative 1c is equal to 2d minus x. And this is where what's the opposite of multiplying by negative 1? Dividing by negative 1. So we don't get the fraction all over again, but we did solve for our variable c. So hopefully that quick erase was all right with you, and you recognize why. We did the same thing in 15, where to get rid of that denominator of 2, I multiplied both sides by 2. If the denominator was 5, I would multiply both sides by 5. So to undo, all right, you're done. There we go. Negative 1 changes that 2d to a negative, and the negative 1 changes that negative x to a positive. So I just swap them around. So it's a lot of, properties going on right now. Either one of those are right. Either one of those will make your teacher proud, because guess what? I'm proud. Yes, I am. Because you're here, you're getting that help. So, we were talking about that denominator. So if we can get this stuff out of here, we'll see if the next ones still are being divided by 2. Or maybe they may be divided by a. Or who knows? Let's see. No, we know, 5. So how do I undo dividing by 5? Multiply by 5. So let's see how we look at it. P plus 9 all divided by 5 is equal to R. And if I want to solve for P, I'm going to have to go ahead and get rid of the denominator of 5. So again, if I write it all out, that would be the top 5 times P plus 9. And then 5 will go into 5 one time, leaving me with P plus 9. And then of course, R times 5 will give me 5R. So now just subtract 9 from both sides. And there's nothing left but P. P is equal to 5R minus 9. Now, as we recognize what happened before we had it being divided by 2, and the other ones was divided by 2, and this one was divided by 5. So anytime you see a anytime you see a variable that's being divided, and you need to solve that variable, of course you're thinking the opposite of dividing by blank is multiplying by blank. Showing those beautiful little step lines there, my beautiful green, but let's get to 18. And b minus 4z, all divided by 7, is equal to a. So the minute I see that, I know what I'm doing, I'm like, I gotta get rid of that 7. I know that's what you're gonna make me do. No big deal. Multiply both sides, the entire thing by 7. So here it is again, where I write it all out. 7 times the top, so 7 times the binomial b minus 4z. And that will all be over 7, because 1 times 7 is 7. The 7's cancel, and that's what we wanted. Now, I never wrote a times 7 on there. We go, 7a. And here we go now, we got that b minus 4z. It's going to equal 7a. And to solve for b, I just need to get rid of what's being subtracted from it. So So we're going to add 4z to both sides, and b is now going to equal 7a plus 4z. 4z. I love it. All right, beautiful box. All right, box might not be beautiful. And now 17, 18. So guys, we're getting into about 20 minutes of our video, and if I'm not mistaken, I believe you're catching on. One step, two step, multi-step, but dealing with the formulas and dealing with an equation that has more letters than it actually has numbers, it can be intimidating. But getting your practice in, knowing what you're doing, you're going to be just fine. So I believe we're coming up to the end of our handout here and the end of our video, but let's make sure we get in everything that we can. The value of a box V is given by the formula V equals LWH. The volume is equal to the length times the width times the height. Where L is the length, W is the width, and H is the height. Solve for the formula for H. All right, so undo what's happening in H. H is being multiplied by LW. Now instead of multiplying is dividing, so I divide both sides by LW, and I am done. Yes, that's it. I know I'm talking softly because yeah, that's it. You know, we get loud and excited with it, but there's other people on this channel for that. Here we go. B. What is the height of a box with a value of 50 cubic meters, length of 10 meters, and a width of 2 meters? Oh, 50 cubic. The volume of 50 cubic meters. What is the height? So they want to know H. What is the height? So we're solving for H. I can plug in length, so put in 10. I can plug in width, so put in 2. Come on now, where's my 2? Oh, I'm gonna get fancy with it. Fancy, huh? Fancy. And H. So 50 is equal to 20H. Go ahead and divide both sides by 20 so that H can get by itself. And I really don't know how many times 20 is going to 50. Yeah, let's figure it out. How many times is 2 going to 5? Figure it out. So 5 halves is what H is equal to. And you can be good with that, or you can actually write it correctly. 2.5. And that'd be meters. So if they ask me in words, I like to answer in words. But sometimes, like my students, I just, oh wait, is that gonna be 2.5 meters? Good enough, huh? I mean, I can put a full sentence, but that's a beautiful box answer. I think we got it, guys. So again, moving on to 19, we finally saw a formula. And whether they said to solve for W or solve for L, it's all good in the hood, right? So 20, I believe this might be our last one. Trent purchases 44 euros worth of souvenirs while on vacation in France. Euros. You ever had a euro? No, you cannot get them at In-N-Out. If $1 US is equal to 0 and 678,000 euros, find the cost of souvenirs in the United States dollars. Round to the nearest cent. Well, this is where I say, hey, you don't like it? Tell me in the comment, because I'm done. Guys, these videos are going to stay at a nice time frame for you. We did a great job of going over these formulas, solving for a particular variable, and we absolutely knocked out that objective today. Can't wait to see you guys in the next video. BMB out.